and keep your microphones muted. We will be recording this session. If we're not recording, I believe, no, looks like we are recording. That's great. Super. And also, the reason we're recording is so that we can share this presentation and make it available from our website and on our YouTube channel. This is a list of our post leaders. You just heard Brian speaking. That was Brian Osborne. I'm the vice president, and we'll be hearing from our other leaders as we go through the presentations. We go through the presentation slides. I am the program chair, so to lay out our program for 2025, in early May, we'll be having our golf tournament, and I'm sure we'll hear more from Ken on that. Also in June, we'll be having our regular resilience discussion led by Mick Bilney, and that will be live at the Wiesbaden Entertainment Center in Heidelberg. We'll also be looking at microgrids in July, outlook on construction in August. We'll be discussing our support for STEM in September, and becoming a civilian from a service member in October, as well as we will be lining up a program for December, hopefully, for our Christmas program. Otherwise, over to membership. Chris.
Thank you. Good morning to everybody. We started the year strong, luckily, because we have 11 new members that joined the post in 2025. And this is so a welcome to all the new members, and a big thank you for the existing member that continue providing support to this post. So I'm glad that we have good participation today, and we'll look forward to engage everybody during this year and follow on. The next slide, please. Present the companies that are supporting the post, and we have one company that joined the post in 2025, Atkins Reales. Actually, they were already standing members. They had a hiatus and then now are back in supporting, and we have a total of 31 sustaining companies in this year. And the next slide shows all the companies that are now supporting the post. So a big thank you to all of these companies. Over.
Thank you, Chris. Now we'll move over to our young members, and over to our young members leader that we have on the call. Nick Irwin on the call. If not, then I will just mention that we do have resources for mentoring and leadership throughout the SAME organization, SAME, and you can join webinars, and there is a link here on this presentation for you. We serve as a network for young professionals so that government and industry can meet and speak. And any questions on our young professionals program, please reach out to Nick Irwin. And Ken Staley, VP Scholarship. We have Ken on the line. If not, we do support high school people going to the university with scholarships for education and engineering for the most part. We have a process through which we select candidates, and you can access all of that information through the links on this screen. Otherwise, if you have questions, please reach out to Ken Staley. As part of our efforts to support STEM and the scholarship, we do have our annual golf tournament. It will be hosted on the 9th of May at the Rhein-Main golf course in Wiesbaden, Germany. You can sign up for that to sponsor with your company, which I think secures you a team for people for which then can participate, or you can participate as an individual. This is really a strong part of our posts program in that we raise a majority of our scholarship funds through this golfing tournament, and we would be delighted if you participate in that. And I know that Ken has sent out some reminders of late to encourage people to participate on that. So if you can, that would be fantastic. We would love to see you out in Wiesbaden. And the theme this year is Hawaii, and you can show up wearing your best Hawaiian shirt. Hopefully the weather will also support that theme. And I think we have Scott Turrigan, who's responsible for the good weather on the day of the golf tournament. We also have our Vice President of Publicity and Outreach, Chandler Ogden. Chandler, are you on the line? Okay. Chandler reaches out in a number of ways. He keeps our Rhein-Main Post website up to speed, and there's a link for it there. Through that, you can keep up to date with what's going on with our post, as well as he sends out news flashes on a regular basis to make sure you know of these events that we have and can stay up to date and participate in them. Also, so there is the link to our YouTube channel that we have, and that has all of our recordings of our programs that we have, and you can catch up on those there. I guess the most relevant one being our 28th January event, where we had 2,108 views on that. Otherwise, any questions or comments can be put out to Chandler, and there is his email at jacobs.com. Thanks, Chandler. Now on to today's event, which is we will be discussing PFAS. We are joined by a distinguished panel. I will briefly introduce them. I would be happy if they, when they're speaking, if they would introduce themselves. That would be great. But before I get to the introductions, I would say working with this group has been tremendous. And when we were putting together this panel discussion and discussing what we would be talking about today, I'm going to do a little bit of a spoiler alert and just kind of lay it out for you. We did not want to talk about just PFAS in general, because we think that the group of people in our audience today are probably pretty up to speed with the basic knowledge of PFAS. But what we really wanted to discuss was, which is why definitions matter. When we talk about definitions, we're talking about the chemistry, we're talking about the legislation, which is why there's a national perspective, and even the local perspective, which are the site conditions. So today's panel discussions will be broken down into chemistry, legislation, national legislation, and site conditions, and how those three elements could possibly drive your remediation solution for PFAS. And just to walk us through, again, who will be presenting today, we're delighted to have Rosa Gwinn from AECOM, who will be going through the chemistry portion. We have Pierre Davit from WSP, who will be talking about national legislation. And we have Cassian Gruber from Geiger in Germany, who will be talking about examples of remediation and site conditions. And we're also joined, we're lucky to have with us today, Rick Wice, who is with Sundance in the US. And at the same time, he leads the environmental community of interest with SAME. And through this panel discussion today, we're really checking a number of boxes on our post objectives that we have for this year, one of which is connecting with our community of interests. And so we're delighted to have Rick as a representative for that. To get us started on our discussion today, I am going to stop sharing. And Rosa, I guess you are going to share your presentation and then I'll hand it back. But Rosa, over to you. Thank you.
All right, Tim, thank you and good morning, everybody. Can I get an audible that my screen is visible?
Your screen is visible and you are ready to roll.
I am ready to roll. So, yeah, not everybody loves the chemistry, and I'm going to keep it light. I think I'm going to keep it light. But I do want to cover a few basics that I think will give us some levers just overall to help us solve PFAS dilemmas that we might encounter. So by way of introduction, I'm Rosa Gwinn. I'm AECOM's global technical lead for PFAS, and happy to be here today. So yeah, big word slide. Thanks, Rosa. Well, here we are. We're going to have to go through a few definitions, and it won't be too painful, I promise. I want to remind people that because PFAS is a large class of chemicals, we have to define sort of what those boundaries are. It's sort of like what makes a dog, right? Well, what makes a PFAS a PFAS? And Bob Buck, who I had the pleasure of meeting, came up with a definition that focused on aliphatic substances. Not everybody remembers what that is, so I drew a picture. A bunch of carbons connected to one another, saturated with hydrogen atoms. No big deal, right? We recognize things like sugars and starches, and we get it, right? So it's organic chemistry here, right? But in the next little bit of highlighted font there, I got all this formula. What's going on? What it's telling you is you pluck those hydrogens off and replace them with fluorines for one or more of those carbons, and you've got yourself a PFAS. Okay, so just that's what that is. And we got this end one where all the fluorine hydrogen got pulled off and whammo, you got fluorine attached. Well, OECD really defines PFAS, especially for operators and practitioners in Europe. That's the Bible. That's where you go. And OECD rather says, that's great, but we want to just say, these are compounds that have one fully fluorinated carbon, either in the end or in the middle, right? And that's a little bit different from one that's fully fluorinated at the end. So there, it took that one at the end and added a carbon that was in the middle and stuck a bunch of fluorines on it. All right, no big deal. And just remember, that carbon fluorine bond's pretty strong. And so that's what gives these compounds stability. And then the United States goes out and decides that the EPA is going to create a definition, and it might not surprise you, but there are about 3 or 4 definitions of PFAS under the US EPA. So the regulations differ. They say, you know what? You can have these kind of wacky compounds. At first, they said these carbons that are fluorinated have to be adjacent. And then they said, no, they don't have to be adjacent. And so you start to get some weird looking chemistry. See how different some of those compounds are? They don't have just a chain of carbons. And what this does is this expands the definition of PFAS so that right now we have about 15,000 compounds in the US EPA computational toxicology database of PFAS. 15,000, right? It's a finite number, but it's a large number. Okay, now, again, chemistry isn't everybody's favorite topic, and I think a picture is worth 1,000 words, right? I came up with that myself. So I'm just going to remind you of a basic concept, and that has to do with this fact that there are both perfluorinated compounds and polyfluorinated compounds in that jumble of words that makes up PFAS. And the perfluorinated compounds, by definition now, are fully fluorinated, meaning every carbons are depicted with these gray balls here. Every carbon is bonded to fluorines, no hydrogens on it. And the fluorines in this graphic are these green balls. And this thing at the end here that looks a little bit like an alien probe, that's the functional group, and the rest of it is called the tail. Okay, no big deal. And so the functional group can react, and it sure looks like it can. There's red and yellow on there. the tail is really stable. Okay, so you always hear, oh, PFAS are completely stable. Well, wait a second, folks. Go over to the polyfluorinated compounds, which are included in the definition. And what you have is the same string of carbons, the aliphatic compounds. And in this case, in this example, notice that instead of fluorine, the green, these are bonded to hydrogen, depicted with the white balls. And what this means is while the carbon-fluorine bonds are very strong, the carbon-hydrogen bonds are not as strong, and you can break this compound apart at this area of weakness. And why that matters is when you hear that perfluorinated compounds are stable, you can't forget that they're polyfluorinated compounds that can alter themselves in the environment. They can transform, is the word, and turn themselves into perfluorinated compounds. Okay, well, as if this weren't complicated enough, I'm going to hit you with a table that might make your eyes cross. But I promise we can get through this together. So let's zoom way out. I've given you these definitions, and now I've put it on a family tree so big I had to flip it on its side. PFAS over there on the left, writ large, comes into two categories. The polymers, which we don't really talk about, like Teflon and so forth, and the non-polymers. And when I say we don't talk about them, I say they're less regulated, but not entirely unregulated. But we focus on the non-polymers because that's where the host of regulations really is focusing in on. And if you walk yourself across those yellow boxes at the top, those increasingly are where we focus our regs. Non-polymers, perfluorinated, and in this family of carboxylic and sulfonic acids. I gave you a picture of one earlier. Okay, it gets a little more tricky, and so just hang on. We talk about short chain PFAS. Those are PFAS with 6 or fewer carbon atoms in them. Okay, and you'll see I highlighted a short chain polyfluorinated compound, a pair down there. So we have the short chains and we have the long chains. And people often believe that the short chains were less toxic than the long chains, right? We don't have tox data on everything. The long chains certainly are of great concern, but on this chart, and I know it's an alphabet soup, over there, squeezed up in the far upper right is trifluoroacetic acid, which does get a lot of attention in Europe and less in the United States. And now remember I talked about the polyfluorinated compounds that can turn into these problematic compounds? That is all of these host of green I show on this chart. So when we talk about PFAS, and we often focus in on PFAS or PFOA, sometimes Gen X, we really need to be thinking about this soup of PFAS because these ones highlighted in green have the potential to turn into the perfluorinated compounds. Okay, why did I go through all this? Well, because you can take the chemistry at a project site and use it to your advantage to understand what's going on. And here's a real simple example of that. I just gave you a landscape, and we're going to come in and we're going to install a bunch of wells because we think that there are one or more PFAS sources at this fictional site. And, just for sake of argument, groundwater is moving to the southwest here. Okay, well, let's just go ahead and measure those PFAS. And I might tell you where the PFAS is and what concentration, but here's the thing. What if I measured those PFAS and in this fancy chart, which is a spidergram or a radar plot, they're sometimes called, I took those compounds that I just told you about, the short chain and the long chain perfluorinated compounds, and charted them all together. So let's just focus on that chart right there in the upper middle. PFBA, short chain, PFPEA, slightly longer chain, PFHXA, longer, all the way around to PFNA. Those are the carboxylic acids, and then likewise short to long on the left side for the sulfonic acids. Actually, there's a slight weirdness there. So, and you see this pattern and it just pops right out at you and you're like, okay, well, these things seem to be related. And then at this other site, and by the way, these are data from a real site, we had a totally different pattern. And this is telling you through the chemistry, we have two different kinds of sources of PFAS, right? This is good in your site studies and site characterization. Okay, well, what about when you want to do cleanup? When you want to do cleanup, you've got all this soup of PFAS out there, right? Does it matter? Does it matter to your treatment system? Depends on what you're doing. So I want you to make sure you understand, oh God, Rosa made this so complicated, but here's a way to make things seem a little bit simpler in practical terms when you're doing a cleanup. And if you're going to go out and just do some big gross removal, just a gross removal action, you're going to dig up some soil or you're going to slurp groundwater out, the system doesn't matter, doesn't care which PFAS you got there, short chain, long chain, precursors, polyfluorinated, perfluorinated, they just get dug up together or they get slurped out together. So I want you to think about that. Like, we make it so complicated, but we can also make it very simple. So with that, I think I can just turn this over to the folks who are going to talk about the regulations, and over back to you, Tim, and the group.
Fantastic. Thank you, Rosa. When you say complicated and simple, I'm such a simple guy that that's just so helpful that you talk about slurping and digging and dumping, and that all makes a difference. And it did kind of drive why we named this panel discussion, why definitions matter, because when we talk about non-polymers, where regulations are focused, short chain, long chain, it moves us to our next topic, which is the legislation in Europe. And for that, we have Jean-Pierre Davit from WSP. So I have your slides here. Jean-Pierre, you can just take it from here. Jean-Pierre.
Thank you. Yeah, thank you, Tim. Can you hear me well?
Yes, we can. Thank you.
Okay, thank you. So I'm Jean-Pierre Davit. I'm based in Italy, and I'm one of the leaders of the practice area for PFAS for WSP, and I'm responsible for Central Europe. So in this slide, and I'm currently in a parking lot in Germany because I'm in a family vacation. So that's why you can see this strange light on my face. So, okay, back to the slides. So in these slides, I try to depict the European regulations on PFAS. So you will see three yellow dots. Those are the updates to the Stockholm Convention, which are the one that started many of these regulations. So in 2009, PFAS was the first included in the Stockholm Convention, and then we got PFOA and PFA checks. On the other side, we have had a series of European directives or regulations, which are basically with a double focus. One is in fixing criteria on waters. So we had the first one in 2013, fixing the environmental quality standards for PFOS. And then we have had more recently the 2020 EU directive on drinking water. And then we have had a number of other directives which are all dedicated to restriction of production of use on different PFAS, but generally always the carboxylics or the other acid or the sulfonate acids. So we have had PFOS, PFOA, PFA checks, PFH access, and a number of other restriction in food products, etc. We have also had finally some other proposed directive, which are basically aimed at an additional restriction of all the PFAS. Those have been subject to a lot of discussion, and the deadline for returning back with the results of the assessment is delayed of at least 1 year. And there is also another one, which is a proposal, and we will see that later on, to amend the 2020 Water Directive. So there has been a lot of regulation in relation to PFAS, and you see that it has been accelerating in the last years. So also in this path, we have been seeing a number of PFAS monitored additioned and increased, and also an increasing number of regulated matrices. So you can move to the next slide, Tim. So in this slide, we show the countries which more or less have fixed some criteria or regulation in groundwater, because Europe as a whole do not have a strict directive on groundwater, on criteria to be met. So you will see that there is different approaches. There is the states in the central stripe, let's call it, have some form of regulation. Some states only have regional regulation and not national. So Germany has some national regulation, but then the different states may have different regulations. Some states have criteria for selected individual PFAS, while others have bundle of a sum of 4, of 11, or 20, or 24. And in general, the sum is equal or lower to a drinking water standard of 100 nanogram per liter for 20 PFAS. So if you can move to the next slide. And if we look now at wastewater, we see that wastewater are much less regulated. So there are only 2 states with regulation on water discharge, which are France and Netherlands. And we see that basically the numbers vary between 20 and 50 nanogram per liter. So these numbers are pretty low, especially if you have to sample a matrix like wastewater, which is not clean. There's a lot of other things inside often. So it's difficult analytically to be able to go as low as with these numbers. In Italy, we also had a regional legislation which has put the same number for PFOS that we have as a as an environmental quality standard, which is 0.65 nanogram per liter. And that number is extremely low because in Europe it has been fixed as an annual average of the quality of the main rivers, while in the region where I live, 0.65 nanogram per liter has been fixed as a standard for discharging water into any shallow water body, which means that now the municipal water treatment of the city in which I live, they have issues because they are not able to reach the criteria for PFOS. So if we move to the next slide. In soil, the picture is again a bit different. PFAS are not regulated in soil in Europe, but some member states have developed their regulation, and we see here. So we have the screening levels are generally in soil, but in some places, like in Germany, the criteria, the law fixes the leachate concentration. Some states fix limits only for PFOS and PFOA, while others for individual PFAS, and others for the sum or 9 or 11 PFAS. In general, there is consideration for reuse and for type of soil, so residential or industrial. And the screening levels may be few microgram per liter, and in general, the industrial use is around 100 microgram per kilogram. Sorry, the screening levels are in the range of microgram per kilogram. So we can now move to the next slide. So what we what we did was to try to put together some consideration about how these different numbers and way to look at the and way to sum up the PFAS may affect the type of technologies we are considering. So with respect of a liquid matrix, and this include from the groundwater to the drinking water to a discharge water. So in the legislation, the trend is to fix criteria for some of PFAS, but that, as was mentioned before by Rosa, means grouping together compounds which are behaving chemically very differently one from the other. And also there is an increasing number of substances to be monitored. Some only fix for 2, PFOS and PFOA, while other includes much more. The technologies, consolidated technologies for removal are mainly absorption-based technique, which for groundwater would mean pump and treat with activated carbons. But we should consider that the presence of co-contaminants, the total concentrations themselves, so whether we are talking with a water which is contaminated with few tens of nanogram per liter compared to some with microgram per liter or milligram per liter. So the type of the effectiveness of the technology, and of course the cost is very different. So in this small graph here, I don't report consideration with respect of the type of concentration of the presence of co-contaminants, but only with respect of the sources. So what does it with the type of PFAS to be considered by the law? So we have if we have only consideration with PFOS and only law, which fix criteria for PFOS and PFOA, there is a high number of technologies that work. There are consolidated separation technologies, so granular activated carbon, ion exchange resins, reverse osmosis of foam fractionation. They do work well for these compounds. And also the emerging destruction technologies like electrooxidation, supercritical water oxidation, they tend to have a high efficiency. But if we start to add to the number of PFAS that are object of restriction, so that we have to monitor and treat, the things start to change. So if we add the long chain PFAS, it is starting to become more difficult for the destruction technology, because you may break down long chain PFAS into shorter ones which are regulated. But more or less for granular activated carbon, RO, it is similar. If we also add the short chain PFAS, so down to the PFBA, perfluorobutane, we see a reduced efficiency on both consolidated and emerging technologies. That means that with normal time, with the treatment time or a residence time into an activated carbon, when you may have 99% removal of PFOS and 50 to 60% of PFBA. So activated carbon will work. You will just need to add much more than what will be needed for PFOS and PFOA. In the same work, the same is for the destruction technologies, because the electrooxidation will tend to have much more difficulties in breaking down the shorter chain PFAS. And if you also add the ultra short chain, which are the one like trifluoroacetic acid, TFA, which is being discussed these days, it becomes much more difficult. And there is also much less literature. So reverse osmosis has been indicated as a technology that may work for TFA, but what we see is that there is a big restriction on the number of technologies that can work. The more broad you consider the type of PFAS to be treated, and as such, cost and difficulty of treatment will increase. If we move to the last slide, here is for soil or solid matrices. So we have seen that the states fix criteria, again, some only for P4 and PFOS, and I would say this is the majority, but other also add other chain or other PFAS. So with respect of the technologies, the only destruction consolidated technology is incineration. but there are others which can be used, also depending on the type of PFAS that you have to monitor, for our immobilization technology, so then filling, engineering containment, stabilization, solidification, or separation technology, like soil washing. So soil washing will depend mainly on the type of soil you have to deal. Whether it contains a large amount of fines or not. But if we look again to looking at what happens in different states, depending on the regulation they have. If some states have no regulation for soil. In Italy, there has been a lot of talk about having groundwater regulation, and at the moment, it will not be elevated to the same level as other contaminants, but not for soil. We have some criteria for soil, but they do not take into account lixiviation, so which brings to a very high level, to a very high criteria in soil. But in fact, if you take into account lixiviation, the number go very low into the microgram per kilogram range. So if in a state there is no regulation on soil, there is no treatment, no capping to be done, which means that ongoing lixiviation may impact groundwater. And that means that if you have a groundwater criteria to be reached, you are better also to do something with your soil. There is also no reuse limitation because PFAS will not be analyzed. But on the other side, there is potential for important contamination in backfill if we do an excavation. If a state has regulated PFAS before and long chain, we have seen that lixiviation is the factor that drive the risk assessment SSTL. But there are a number of technologies that can be adopted. In general, the states which have fixed criteria for PFOS and P4, they will also have a strong limitation to reuse of soil because the criteria become immediately very low, the number of microgram per kilogram. But on the other side, there is a lower risk of importing soil contamination. If you add short chain PFAS, some technology will be affected, like stabilization, solidification, but for the others, it won't change much. If you excavate and you put it in a landfill, it won't change much. What may change is adding the ultra short chain or top assay results. So the consideration not only for the perfluorinated carboxylic or sulfonate acids, but all the other polyfluorinated compounds that may act as a precursor to be treated in the soil. Again, there is not much difference if you have to excavate and bring it to a landfill, but for treatment, that may change the game, as well as the potential need for treating TFA, of which there is very little literature about. I hear some strong noise.
I do too. If everybody can make sure you're on mute, that would be great.
Okay.
Okay. Yeah.
Okay, and with this, I'm finished. So I pass it to the next one.
Yeah, you pass it back to me. Thank you, Jean-Pierre. Just fascinating of how we started with the chemistry and how that could drive your remediation strategy. Pump and treat versus dig and dump. And then how just a small focus on legislation and how we see that long chains, as Jean-Pierre was saying, are typically in focus in legislation, which if you have it in drinking water, and there's set criteria for those compounds there, that may drive your remediation strategy in terms of, in order to get to the groundwater criteria levels, regulatory levels, you may need to look at your soil conditions and soil. So with that, if you're an opera fan, you know that really the most action is packed into the third act. So we've had Act 1, chemistry, Act 2, legislation, and now Act 3, heading into site conditions. So for that, I hand over to Cassian Gruber with Geiger, and I have your slides here as well. Cassian, are you there?
Thank you very much. Can everybody hear me?
Yes, we can.
Great, thanks. My name is Cassian Gruber. I'm leading the environmental business at Geiger. Geiger is a construction company in Germany, operating mainly in Germany, but also some other European countries, Italy, Austria, France, and Luxembourg. If you move to the next slide, please. Perfect. Thanks. I'd like to talk about three things today. First of all, I would like to look at some remediation methods, and especially what can you apply under which conditions, and really from a practical perspective, if you do the cleanup, which Rosa mentioned before, how would you do it and what would you need to consider? And then I would like to share some examples, like really from the groundwork, where did we apply some of these methods successfully, just show some project examples for you. And I think then the Q&A, I think we'll do later on. Thank you very much. So in terms, how do we look at that? What we see is if you have a PFAS contamination of any kind of chemistry, this happened somewhere at some kind of site, and Rosa showed the example before. Where do they come from? They come from like some fire departments who did some training work. They come from some agricultural work, or they come from the PFAS production. If you want to work these sites, you need to look at how the soil is actually, what's the composition of the soil. And here we differentiate between really gravel rather than sand, slit, and clay. And why am I saying this? And Pierre already built on this, that soil washing doesn't work everywhere, for example. Not all the methods, which you can see on the top here, technical structures, pits and quarries, soil washing, landfills, underground recovery, and the thermal destruction, work with every kind of soil. What are the different things I'm talking about in the top line? The technical structures is typically dams for noise protection or for flooding protection. That's quite common in Germany. It depends a little bit on the region where you're in, how you can do that. But this is a common thing where you can actually store soil depending on the contamination, of course. Then you have pits and quarries. Depends where you are in Germany. In Bavaria, it's possible to backfill them. In many other places, you cannot put any contaminated soils there. It depends. Then you have the soil washing. I think the concept is clear. The landfills, where you then really have a controlled landfill with some water treatment of the leachate. And then you have the underground recovery, where you really put it in some kind of mines, old mines, which are backfilled. And then last but not least, the thermal destruction process, where you get the PFAS into the gas, and then in the afterburner, really at really high temperature, you burn it. Obviously, the cost increases dramatically when you look at these kind of methods. So you would typically try to start on the left, whatever how your contamination is and how your condition in the soil is. You would try to put it in a technical structure if you can. If this is not possible, you try to soil wash, but here you really need to check, it doesn't work. It does only work with gravel and sand. It does not really work well with slit or clay. And if this doesn't work, then you need to choose other methods, which I showed here. If you would move to the next slide, I would like to show some examples. Where did we do that? For example, in Frankfurt, at the Frankfurt Airport, classic site for PFAS contamination, firefighting foam, 400,000 metric tons of contaminated soil there. We helped them to remove that classic dig and dump. It's really a sandy soil. Back then, we already wanted to implement some soil washing on site. It would have worked, we are pretty sure. Unfortunately, the operating time frame was just too short. The soil had to go very, very fast, and so it went into landfills and technical structures. If you would move to the next slide. A really interesting project, which lasted for almost 6 years, was in Ingolstadt. It was an old industrial site with a lot of PFAS contamination, firefighting foam. It was a refinery. And here we washed soil because it was really gravel from the river Danube, which is really close by, with a small amount of slit, 150,000 metric tons. We did this together with Strabag and Süblin, and implemented the plant, which you can actually see in the picture, and that worked really, really well. And a lot of the washed gravel then could be actually backfilled into the site as clean gravel in the end. For the US Army, we did some work in Grafenwöhr. Here it was really interesting. We wanted to do some soil washing here as well, but there have been quite some challenges because it was gravel, but it was really porous. So the PFAS really went into the stone, and it was not possible to wash it in a proper way. So it had to go into the landfill, and that for us was an interesting point to say not all gravel can just be washed. You need to really try it, and you need to watch where you are, in which region you're actually operating. And then if you move to the last slide, please. It was an industrial site. Interesting because here it was actually from the PFAS production, so where it all comes from. And here we had a lot of soil which need to be removed from the site. It was like 65,000 metric tons. It was gravel, it was mixed materials. Also, we wanted to implement some soil washing there as well, because we think it would have been the best and also a very economic choice. But time matters here as well. For the follow-up construction, they wanted to have it gone really, really quickly. And so it went into the landfill as well. I think these were all the slides. Thank you very much.
Excellent. Thank you, Cassian. Very good time management on all of our panelists. I really appreciate that. I am going to stop sharing now because I believe Rick Wice wanted to drive his slides himself. Is that correct, Rick? Have Rick?
Actually, do you actually have them, Tim? Do you
I
have
do.
them? Yeah, why don't you go ahead and drive for me, please? I've got two screens and screw up.
Yeah.
Hey, good morning,
problem.
Okay. Good morning, everybody. My name is Rick Wice, and I'm the former chair of I'm with Sundance Consultants, a U.S. firm. I am actually the former chair of the Environmental Community of Interest, but along with Bill Giuseppe of Jacobs in 2021, you can show up, you got the first slide up there?
Coming up. Yep, just a second.
Yep, okay. Let's see. Okay, great. Should be coming up. Okay, super. Yeah, Semi-National has really put a lot of focus the last 4 or 5 years on the technical COIs and the industry government engagement program. And one of the initiatives was basically to tackle challenges to the Sami community, like resiliency and climate change and PFAS. And PFAS is a pretty big thing. So I was approached by National, asked if the Environmental Community of Interest, would put together a PFAS IGE. And as I said a minute ago, I reached out to my friend Bill Giuseppe at Jacobs. He was the first project manager. I was sort of the COI sponsor. And I also want to note that Rosa Gwinn from AECOM has been a significant player, participant, and contributed to this effort. So we basically got together a lot of stakeholders, because as you've seen from the slides we've so far, PFAS is a pretty complex topic. A lot of aspects to it: the chemistry, the nomenclature, the regulations, the technologies, and we haven't even covered some of the fate and transport issues or issues related to AFFF. So this was basically a project to come up with a way to present to the SAME community fact sheets and webinars that explain the complexities of PFAS in a more simpler way than what we've seen in some of the technical associations, or in the States here we have a thing called the Interstate Technology and Regulatory Council, and these are like massive guidance documents, and we wanted to come together and put things together that would be more simple. Next slide. Great. So basically, like I said, 2021, Bill put it together. We wanted to have digestible, discernible, and easy to read fact sheets and webinars to help the community understand this problem. And there's the letter from the National Executive Committee to say, you guys got to go ahead, start it. And what's unique about the PFAS IGE, the IGEs all had like a 1 or 2 or 3 year timeline. We've been going for 4 years, and we still look forward to another couple years of activity. Next slide, please. So we have a lot of participants. We have 45 to 50 individuals from the SAME community. We have consultants, we have people from laboratories, we have folks focusing on research and development, and we have some of the technology vendors involved. We have large businesses and small businesses. But what really makes this IGE really great is the fact that we've got participation from folks from the Office of the Secretary of Defense, the National Park Service, the Navy, National Guard, Army Corps of Engineers, the Coast Guard, and the U.S. Public Health Service. And we actually, when we put together our fact sheets, we send them to various reviewers from the government for their input, and then they all get final review from the Office of Secretary of Defense. And the reason that happens is PFAS in the States is a very hot issue. There's a lot of litigation, there's a lot of liability, a lot of concern. So we just, in cooperation with the Office of Secretary of Defense, asked them to do a review and a tweaking. So we're not really backing the, and then once again, it's IGE, so it's industry and government. We don't want to be backing the government to a position that causes them any difficulties. Next slide, please. So what have we accomplished so far? Well, basically, if you want to find out, real important, if you want to access the information we put together, go to the SAME website, go to the Environmental Community of Interest, and you click on the right there. There's archives, which has videos of some of our previous presentations, and also if you see down there is a tab, PFAS information sheets. So we have everything we've done has been posted and it's accessible. Also, I think if everybody gets the numerous emails from National, as well as probably from your own post, about all the upcoming webinars. So our webinars are advertised well in advance. They're supplemental to the webinar Wednesdays that the ECOI does. So we have several fact sheets and some of the fact sheets now are actually being updated since they've been started in 2021. Regulations and technologies and case studies have become more numerous and changing. We have an introduction to PFAS. We've got sampling considerations, regulations, and other organizations' activities that's being updated. And we also got some on considerations of wastewater and stormwater. And we have a few on we had a few webinars so far also on like some treatment technologies and how to deal with IDW disposal, and the most recent webinar was on AFFF. Next slide, please. And fact sheets usually lag 1 or 2 or maybe more months from the webinar. Our goal, this is what one of our fact sheets looks like. PFAS considerations in wastewater and stormwater permitting. There are 2 pages. We want to keep it simple. It's got contact information if you're interested in the ECOI or even joining. This is open membership. If you want to contribute PFAS IGE, please do. You may have a great case study. It may become a webinar Wednesday, or we're looking for people to participate and share their knowledge. So they're pretty basic, pretty simple. You could download them from the SAME website. And one of our goals was to try to get these fact sheets distributed through the DoD entities to like people who need to know more about PFAS. And they kind of like to stick to their own. If it's Army, we give out our Army fact sheet. If it's Navy, we give out our Navy fact sheet. But if you have a client or you have in a situation where you're trying to explain PFAS to folks, feel free to use our fact sheets. That's what they're there for. They're for you as the members to have the information at your fingertips for your own use or to share with others to help bring them up to speed to help you make or help for you to help them make decisions on their PFAS management. Next slide, please. So yeah, this is basically what we've done in 2024, 25, just a look back, some of the fact sheets and some of the webinars we put together. We can jump to the next slide. We haven't really put together 2026 yet. So basically what we're trying to do is to have high level, what you need to know to get the job done information. We show no signs of slowing down. We're developing new ideas and we're also updating previous ideas, and we'll probably update, I know Rosa's updating some regulatory stuff, or she has already. And basically there's our COI lead is not me anymore. It's Ann Eway with the Army Corps of Engineers, Kansas City District. I am the past chair and pretty active on the steering committee. And then there's some, Lisa Kammer from Western Solutions is the current project manager for the PFAS IGE. If you're interested, I think she'd love to hear from you and guide you in the right direction. Like I said, we're trying to keep the group moving and growing. And also, if you have an opportunity for further outreach on PFAS, let myself or let Lisa know, and we could arrange to like the call today. So I think that leaves us some really good time here, Tim, for maybe some open discussion and Q&A. Over.
Excellent. Thanks, Rick. You're absolutely right. It does. All of you have been excellent on your time management today, and I really appreciate that. And we already have our first question from Jen Collins. Jen.
Hi. Is it possible to get a copy of all the slides that were shown today?
We'll be making information available. I don't know if they'll be these exact slides, but yes, we will be making information available post panel discussion.
Okay, and then, sorry, my second question is there a SAME organization for Germany? I mean, I had membership in the States, but moving over to Germany, I really haven't heard anything.
Okay, well, Jen, welcome to the SAME Rhein-Main post in Germany post. So you can either reach out to me, or I'm the vice president of the SAME Rhein-Main post. Brian Osborne, who's also on the call, is the president. And then we have Chris Carloni, who is our membership person. He's also on this call. Happy to reach out. And maybe, Chris, you can put your name and email in the chat for Jen so she can contact you. We'd love to have you as a member, Jen.
Okay, thank you so much.
Sure. So any questions for our panel members related to PFAS or any other topic from our audience? If not, I have a question, and this is going to, Rosa, I'm going to ask you a question. So listening to Jean-Pierre on European legislation, and you talked about, and he confirmed that most legislation is focused on, I would say, I'm going to say long chain. Was there anything that surprised you in his analysis of the legislation versus what you see in the U.S.?
Well, I don't know about surprised, although I do like a good surprise. I would say one of the really super interesting things, differentiators between the sort of generalized approach to the universe of PFAS in Europe and the US is, and Cassian, really zeroed in on this, is the attention on soils, right? In the US, we really concentrate on groundwater and surface water, and it's just a flip-flop. And maybe it has to do with Europe overall having, a smaller boundary and, smaller footprint, and every piece of dirt is precious, right? I mean, especially if you live in the Netherlands. But I think that when you look holistically at those regulations in Europe, what I see is um, achievable limits, achievable endpoints, uh, practical practical concepts for protection of the environment, and that leads to action, right? Because you can do it. When limitations like we've seen in the U.S., these ultra low levels, parts per trillion for drinking water, and I mean, limits that are in the parts per quadrillion for soil cleanup, they're unachievable. They're immeasurable and unachievable. So when you look at the Cassian and Jean-Pierre's presentations, what I get is a sense of hope that we can manage the risk without focusing on 100% removal, like every carbon fluorine bond is the enemy. And that's it, like kind of a long-winded response.
No, fantastic. No, that's exactly, that was a great answer. Yep. Rick.
And Rosa, I think the point you make, Rosa, is that we've also seen sort of a delay, pardon the background noise, we have seen such a lack of action on addressing PFAS in the remediation area because of what you just said. There's concrete specific cleanup levels, and we've been going arm waving in the United States. And I think the philosophy isn't started long ago. From my looking at European cleanup, it's always been focused more on the soil than the groundwater. And here, you have defensible cleanup levels in Europe, or at least reasonable ones. In the States, I have not yet had anyone tell me there's toxicology data to back up the detection limit levels that we're working with in the States.
Oh, there is tox data, Rick.
For that low?
Yeah.
Okay,
yeah.
well, I apologize.
That's where it comes from.
Oh, the ISIS, the IRIS, is that the EPA database? Correct me if I made a mistake there.
No, there's tox data, but I mean, everything is controversial, even science, right? We've all learned that in the last 5 or 6 years, right?
Yeah, but when we've been at some of those meetings, I think we have one next week, the biggest contention has been between the toxicologists. So I'm going to rephrase what I said.
Well,
there's still a lot of argument amongst the toxicologists.
Absolutely.
Yeah.
That doesn't mean there's not data. And
all right.
That's really where I'm and peer reviewed and published, right? So.
No, excellent. And I think Jean-Pierre wanted to chime in. Jean-Pierre.
Yeah, just supplement to what Rosa just said. So the picture in Europe is not completely fixed because the ECHA number and the EFSA recommendation on tolerable daily intake are actually lower than what many states have used to fix their soil criteria. So it means those numbers can become lower in the future. There has been some occasions. So a couple of states proposed numbers lower than the one that they currently have. So these were Sweden, yes, and Netherlands. Both states came out with interim values, which were then higher up because they realized they weren't achievable. So maybe there is some sign of some rationale behind it. I hope you can hear me well. I see my connection not very good.
We can hear you fine. We just lost your visual, but video we can hear you. Rick.
Yeah, I have a question. Most of my PFAS work, and I've done some research when I was at Battelle, and I'm also with Carnegie Mellon University with a lot of students there doing in situ carbon, colloidal carbon stuff. What's the this is a general question. What is actually the status of the U.S. military installations in Europe dealing with PFAS? Maybe Rosa, you have an answer to that, or somebody over there in the Rhein-Main post. What's happening?
Or maybe anybody from the Europe district on the call. I think I have an answer, but I'm not sure it's correct. Anybody from the Europe district want to take that question?
while they're thinking about it. Like in the States, we've had a lot of preliminary assessments, SI, we're moving into the RI stage. So there's been a lot of progress in at least identifying potential source areas and impacts, and then doing the site investigation, and then the delineation of the extent studies in the RI. And I'm just kind of wondering, if anything's going on over in our facilities in Europe. Over.
There certainly are things going on in facilities in Europe. One thing I know a little bit to be dangerous. The levels of action, or the actions or requirements that need to be met related to PFAS are driven on base primarily by the status of forces agreement that's in place per country, and those varies depending on where you are. For example, Germany in the status of forces agreement stipulates that the Army bases need to meet or exceed German standards. I'm not sure how that applies to other places, but I know, having done a lot of environmental work on bases here in Germany, that it's the German legislation that drives a lot of the remediation criteria that's associated with PFAS. And then at the same time, there are other things in place within the SOFA that says, investigative wise, the US government is obligated to report certain things, and then the German government may be responsible for actually doing the cleanup. So I know that is in place. I know that there are PFAS investigations going on at US military installations in Europe. I'm not at liberty necessarily to share any details on that, but I know what's going on. You do have the final governing standards in Europe that the US government puts out for installations on environmental issues, and I believe it's fairly silent on remediation criteria because a lot of that is driven by national legislation. I could be wrong on that. I don't know if there's anybody from the Europe district who would like to comment on that.
I think that sounds pretty accurate, Tim. I would say that at the moment, PFAS in drinking water, I believe, isn't yet included, but that'll be coming in at the next update with the new OEBGD. With regard to soil and groundwater, yep, typically driven by the host nation requirements. But I know that some projects were being asked to, in Germany, where soil contamination is based on leachate, we're also being asked to do soil and solid matter by the clients, because that helps them compare globally with the requirements, in the US and elsewhere.
No, thanks, Jane. That was very helpful. I did have kind of a basic question. We talked about freight and transport and stuff like that, or we mentioned it, which we didn't really talk about it. But Cassian, when you were doing soil washing and you said it was successful, congratulations on that. What do you do with the residual, material that you clean out of the soil? What's done with that?
Yeah, it's a good question. Thank you, Tim. So there's basically two things. It's the washing the water. So a lot of the contamination obviously goes into the water, and you need to have a water treatment facility afterwards, which is activated carbon typically, which is used, and then once it's fully loaded, you just put it into the thermal destruction process. That's one. And then you have the really, really fine material. If you wash it, then you have like sludge, and then you press the sludge, and this kind of materials we then put to landfills, which were equipped to have these kind of to handle the contamination. Yeah, for us, the focus here was really to maximize the gravel for the reuse potential for the gravel in the end at the site there.
Excellent, thanks, Cassian. Rosa.
Thank you.
I hope you don't mind my diving in. I wanted to mention something if it didn't come through really distinctly with that response. When we were talking about 150,000 metric tons, 175,000 metric tons of soil, and if you imagine having to manage that because it's PFAS laden, right? That's pretty tough to landfill. Although there are sites where the soil washing isn't going to work. You mentioned the porosity of the gravels at one site. But if you can do what Cassian just mentioned with soil, where you separate and concentrate the PFAS laden portion, then you have something smaller to manage. And the same thing applies to water treatment, whether it's drinking water or groundwater, you name it. And so there are a lot of technologies that were included in Jean-Pierre's presentation that that separate PFAS from water. So I'm going to pretend that I'm operating a drinking water treatment facility that manages 10 million gallons, pardon my British units, 10 million gallons of water per day. Well, if I have to manage that for PFAS, let's say treat it with a destructive technology, there's not enough money in the world to do it. But if I can put something in there to pull out that PFAS and concentrate it, right? All the good clean water goes this way, and those parts per trillion or nanograms per liter zoop, get put into a little teacup, then I can manage that, right? I can destroy that using energy that only destroys that carbon fluorine bond and I don't waste any energy, oxidizing metals or whatever might be in landfill leachate, blah, blah, blah. So if people can take away one thing from my long-winded statement here, it's the key to success for treating PFAS is separate, concentrate, destroy or dispose, right? Just treatment train. You might have to use multiple technologies to do it, and we're smart enough to do that.
Excellent, Rosa. Thank you for taking us full circle there, Rosa, because I do believe, if I'm incorrect, let me know, but I do believe chemistry, legislation, and site conditions will drive your decision-making when it comes to trying to do exactly what you just said. So hopefully that leaves everybody a little bit smarter at the end of our panel discussion. I would very much like to thank all of our panelists for taking the time, one, to prepare during multiple calls before this call, also for time management. We're exactly at the top of the hour now, which is fantastic. Thank you for everybody else who has participated today. It's great to see such a good crowd out here. And then maybe I'll just hand it back, if Brian Osborne is still on the phone, hand it back to our president for the final word. Brian.
Thanks very much, Tim. That was absolutely excellent presentation. I really enjoyed that. I guess I'm a geologist. I've spent a lot of time working in groundwater remediation. Not so much time working with PFAS. So it's really nice to have that very compact, very concentrated, very focused summary from all of our presenters. Fantastic job. Thank you, Rosa, Jean-Pierre, Cassian, and Rick. Very, very good. And we all know separate, concentrate, destroy. Those words we can take with us next time we're talking about PFAS. And as Tim said, some of us know enough to be dangerous. Now we know a little bit more. And also great to know we have those SAME resources out there. So I'll certainly be taking a look at those. Thank you very much to all our panelists. Thank you very much, Tim, for putting this on. Thank you for the good questions. And look forward to seeing people at either the golf tournament in May or joining our next meeting at the Heidelberg Entertainment Center, which will be talking about various aspects of resiliency. Thanks a lot, everybody. Thanks and have a good rest of the day.
Thanks, everybody. Have a good